it can go wrong, it will.
There you go. So we're going to talk about this a little bit. And I know some of y'all are going to roll your eyes and say, God, he's being such a parent. But I have to go through this because some of y'all, meaning students, I'm doing every one of my classes. I've got 4 classes with close to 20 to 25 in each class. So I've got about 10 students or 10 to 12 students that don't think, okay? So we have to stop for the 10%, for the 10 or 12, 15 students that don't know of Murphy's Law. So that's why I'm going through it. Here's Murphy's Law. Anything that can go wrong will. The second thing I'm going to talk about, your failure to plan does not constitute an emergency on my part. And the third thing, we are a product of our own choices. All right? First of all, how many days do I give you to take a test? That means I want somebody to say something.
4.
I give y'all 4 days. When should you not take the test?
The end of the 4th day.
The end of the 4th day at 10 o'clock at night. All right? A good way to take the test is this. This is a good way to take the test. If I give you 4 to 5 days, the first couple of days you need to take the test, see what it's like, see what you need to, improve on, or if you ace it, you're done. The second couple of days, or the second day, or the third day, you might want to take it again after you studied a little bit more. And then the 4th or 5th day, you want to use that day to take it the 3rd time, in case the 1st and 2nd score wasn't your level that you want. That's the way you're supposed to do it.
Priority 1 message.
But no, we have 10 or 15 students that do what? They wait till 10 o'clock Monday night to take all 3 tests, and there might as well be a thunder and lightning storm outside and a dog chewing on the wireless router. Okay? Now, should I kill myself to give you another chance or extend your time when you wasted 3 3/4 days to take the test? Yes or no?
No.
I shouldn't. Okay? All right. That's it. I'm done. I may not even be talking to any of y'all. I think all of y'all did okay. But I have to do this with every single one of my classes because I've got, out of 100 students, I've got 10 or 12 students. I don't know what to do. They act like they're high on drugs or something. Anyway, I'm sorry. I'll get on the math now. Anyway, that's done. Get used to it. You're going to deal with it in the real world too. 10% don't have a clue what's going on. All right, we're going to start with the logarithms and the exponentials. And I already sent you, and you should have looked at the video. I want you to kind of cover a little bit of things. Mainly add this to your family of graphs. That is your graph that is 2 to the x. Go ahead and write that down right quick. Add that to your parent graphs if you haven't already. And we're going to talk about graphing an exponent and solving an exponential. Okay, so graphing an exponential is it's always going to go through that 0, 1, Always going to go through that point, and it's always going to be increasing. So f of x is equal to the x power. And that is your parent graph. Everything else is going to be compared to that graph. All right. Now, what if you were to get a function, say like 32 is equal to the x power, and they told you to solve? That's a test question. All right. Does anybody have any idea how you would solve that? Anybody want to take a guess? Well, remember, when you have an exponential, and we're going to put this in pink. When you have an exponential, the first thing you want to do is try to get equal bases. That's the first thing you want to do. So in this case, you're going to get 2 to the 5th power is equal to the x power. And these bases are the same. Can somebody tell me what the rule is if the bases are the same? Come on, Miss Taylor. I know you got it in you.
The exponents have to be the same?
The exponents are equal to each other, yes. So x is equal to 5. Now, why do I show you this problem before I show you any other problems? Because this problem is going to be on a standardized test or a SAT or an entry-level exam, and you're going to sit there and stare at it because this is the one you forget about. All right? Always try to make the bases the same. Now, what if you can't? Well, then that's when we do the definition of logarithm or take the log of both sides and all that good stuff. Okay? This is an exponential equation. So make sure you make a note of this one. Okay? Are those 2 test questions? Yes. So make sure most of your graphing on exponential powers is going to be on the calculator. So you don't have to worry too much about sketching or doing anything like that. All right. Make sure you make a note of b to the negative x. B to the negative x is going in the opposite direction. So if we're going to do b to the negative x, f g of x is equal to the negative x. Negative x would go in the same direction. I mean, different direction, still passing through the same point. Okay, so make a note of that. You're not going to be able to understand logarithms unless you make sure you understand exponents, and that's why we're going through the exponents. The exponents is kind of a review. So, and there's your vertical and horizontal shifts. The 4 is connected to the x, so therefore it's a horizontal shift 4 to the right. And how do you know what that is? Because there is your 0 and 1. Y'all need to mark that. The 0 and 1 is what you shift. That point right there is what you're going to shift. So if I give you, let me go ahead and do this with you. Let's go with green. And if I give you f of x is equal to the x minus 4. Then I'm going to move that spot. This spot right here is 0, so I'm going to move it 1, 2, 3, 4, and there's my new point. And now, so there is that. So the 4, it is measured from that point right there. And let's do a yellow. And that's going to be f of x is equal to the x minus 4 plus 2. And of course, that's going to be a vertical shift. And they should be showing you that also with the, let's see, there we go. Right there. Now they put it in front. You can put it in front or you can put it in back. It doesn't matter. Still a vertical shift. Okay. So this is going to be minus 4. So that'll be here. And then we've got a vertical shift of 2 up. So that's going to be 1, 2. So there's my new point. And there that is. Okay. So you got your basic graph. You've got your orientation going opposite direction. You've got a horizontal shift of 4 to the right. And you've got a vertical shift of 2 up. So make sure you can do the same things that you've been doing with the graph, only make sure you can do it, you know, with a exponential. Any questions on this? This is a test question, and this is a test question. Capiche? Comprende? Now, with the exponentials, you're going to be dealing with exponential growth. And where is the simple interest? Simple interest is usually in here. I want to show you simple interest. Let's see if they're going to put simple interest in here. Now, there's continuous interest. So we're going to talk about simple interest. Let's go ahead and write those down because I will test you on simple and continuous interest. So let's talk about that. Now, compound interest. Can anybody tell me what compound interest is? A is equal to P times 1 plus R over N raised to the NT power.
It's basically interest on interest, if that's what you're asking.
Yes, in other words, you are calculating every so much time, and not only do you calculate the principal, but you calculate the principal plus what interest you've earned.
Yeah.
And then you've got continuous interest. A is equal to PERT. There used to be a shampoo a long time ago called PERT. And that's why I use the word PERT right here because it kind of spells PERT.
Coming in on secured channel.
And I just remember, I don't know, some of y'all may remember. What?
Isn't it like the VO5 stuff?
It's green. It's a green bottle. It's conditioner. It was one of the first shampoos with conditioner.
Yeah.
It's in a green bottle. It came after Prel. Prel was the shampoo, and then PERT was the. Anyway, I was a kid when it was, so I don't remember much of it. I just remember the commercials. Anyway, P is the principal, which means that's what you put in. Okay. R is the rate. It's usually given in percent, but you have to change it to a decimal. N is the number of times compounded. Think of the word calculate when compounded, because that's what happens. The calculator or the computer goes to a calculation and actually calculates your money. So if it does it once a year, what's that called? What is once a year? What is that called?
Annually?
Annual.
Thank you. So n is equal to 1. That's an annual compounding. So why am I telling you this? Because you ever gone up to a drive-through and asked for a couple of orders of fries or a couple of drinks or a couple of medium Cokes, and the person goes, how many? A couple? How many is that? Well, there are some people that don't know that annual means one time a year. Just like there's some people know that doesn't know that a couple means 2. That's not exaggeration. And a couple, the word couple means 2. Okay?
Like you see a couple, 2 people.
Yeah. But when you go to a drive-through,
Well,
a
they work
couple
at-
doesn't mean 2. It's non-existent in the. So what is n is equal to 2? What if it's 2 times a year?
Biannual.
Semi-annual. Yes, you could say bi-annual, but most people say semi-annual. What's between semi-annual and daily? What's next? N is equal to what? 4?
Quarterly.
Quarterly. Good job. Everybody that has anything to do with business knows what quarterlies are. Does anybody want to know what quarterlies are?
I don't care to know anymore.
Yeah, you have to send Uncle Sam in the state the monies that you have withheld from check stubs. That's called quarterlies. And n is equal to 12.
Monthly.
What word goes with 12?
Monthly.
Monthly. Like I said, I have to teach y'all these words because there are people out there that have gone through 12 years of school and don't know that a couple means couple and annual means once a year.
What about 6? Would that be bi-monthly?
What'd you say?
6 would be bi-monthly or semi-monthly, I guess, depending on what you say.
No, bi-monthly would be 24.
Oh, yeah, that's right. Never mind.
Okay. But they usually do these. These are the most used right here.
Yeah.
So let's do an example, and we'll just do an example with compound interest. Because what's the hard part on doing these problems? Not plugging and chugging. You know what the hardest part with students is doing these problems?
They don't know the terms.
They don't know how to use their calculator.
Oh, that too.
They don't. Okay, so let's see. I won the lottery and I won $10,000.
And you get to keep.
And I don't want to go spend it because I want to figure out how I'm going. So I want to put it in the bank for a while. And I'm going to put it in for 5 years. Oh, I forgot. T is equal to years.
Oh, okay.
Forgot to tell you all that. 5 years and 8%, which is unheard of because now I'll give you an example. I took all of my income tax returns. Did I put it in the bank? No. I put it in stocks. Why?
Yeah, you're going to get much more out of it that way.
Because the bank only gives you like 0.02%. After the recession back in 2004, 2008, whenever that happened, the banks went from 8%, they went to like 0.02%, and they don't come back up very fast. I think now they're up to like 1.5% or 2%. So your money is doing absolutely what?
You had a work
Nothing.
email.
So that's why now you don't get 10% or 8%. You get like 0.02 or 1.5, which is nothing. So I took my income tax return and I put it in the stock market. At least it's doing something.
Mm-hmm.
Okay. And it's compounded monthly. Okay. Now plug and chug. A is equal to 10,000 times 1 plus R 0.08 divided by 12 raised to the 12 times 5 power. Now, you don't have to write anything else down because now you get your handy dandy calculator. Now, what have you been taught ever since the 1st and 2nd grade or 3rd or 4th grade about parentheses? You always work inside what? Inside out, Hubert. That's right, class. So we're going to work on the inside and work our way out. So 0.08 divided by 12. Watch what I do here. Plus 1 raised to the 60th power multiplied by 10,000. And I get 14,898. .46. Now I'm sorry, but 5 years and you get $5,000, that's not bad. Considering you did absolutely what? Nothing. But the problem with this is banks don't do this anymore. So you got to find another way, whether it's cattle or stocks, to put your money in so that it's working, it's doing something. Okay? Now I want you to do the continuous. Do the same thing with these numbers, just continuous. You don't have to do the 1 plus R over N, but I want you to do the continuous with these same numbers. 10,000, R is 8.08, and T is 5. So go ahead and plug that in. Y'all sure are talkative today. Yeah, Hubert, we had a long weekend. Well, that's good. All right, I'm going to do it in green. I'm just going to put it right here. A is equal to 10,000 E 0.08 times 5. And I'm going to plug it in. So take your handy dandy calculator, clear, clear. And we're going to do E, which is second, natural log, and parentheses, 0.08 times 5, close parentheses. It's supposed to be 0.8, Dort. There we go. And I'm going to multiply that by 10,000. We got a big difference, yes or no? Not really. $14,918.25. Now, why am I showing these two together? Because they give you about the same answer. Okay. So you got $918. That's what, $20 difference? So you're not talking about a big difference. Now, is this something that you should know if you learn nothing out of this class? Yes, because this is what banks use. Derivation of these two right here, whether it's compound interest or continuous interest, they use some derivation of that in their savings, CDs, or IRAs, blah, blah, blah. Okay? So make sure you know how to use that, and make sure you know how to punch it in your calculator. And it's always increasing because it is interest, and that's a exponential. Okay, these right here are exponentials. Okay, so it's always increasing. Now the negative would be decay, which would be half-life. And sometimes we get into that also. Yep, there we go. Decay. And I'm going to show you one of those. There it is. You need to write that one down right there. That's your decay formula, especially for carbon dating. Now, do standardized tests love putting these on the test? Yes. Y is equal to a function of t, time, which is equal to the initial e to the negative 0.0001297 t. And I want you to write this example down because we're going to do this example. Okay, so they give you the carbon dating, all this right in here. They give it to you, and they say blah, 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 blah. And then they give you, if the original amount of carbon-14 present in an artifact is 100 grams, how much remains after 2,000 years? And what percent of the original amount of carbon-14 remains after 4,500 years? So go ahead and write that A and B down. The dang old Dogecoin's not making me happy. Damn Russians.
It lost me $100, dropped me from 270 to 165.
Well, I'm in for long haul. I'm
Yeah.
willing to get up $10 so I can retire. If it ever got up to $10, ooh, I'd be doing a dance. And then if my Shiba, if my Shiba ever gets to $1, good grace alive, I'm going to do a dance for sure if that happens. Okay, so what do we do? Well, in the first one, it says if the original amount of carbon-14 present in an artifact is 100 grams, that's going to be your Y sub O. That's your initial amount, 100. And 2,000 years, plug and chug. Now that's where you might run into a little bit of, so that's going to be 2,000, F of 2,000 is equal to 100 e to the negative 0.0001297 t. Okay. And when you do that math and you plug in that 2,000 for t, you're going to get, let's punch it in. So that's going to be E, that's going to be second, let me clear, second natural log, and I'm going to plug in negative 0.00120, oh, 0.00120, 97 times 2,000, because you're supposed to plug in 2,000 for t. And that's equal to that number. And then you're going to multiply that by 100. And that's going to be 78.51. So F of 2,000 is equal to 78.51. And that should be how much is left. And that's grams. I didn't know which, grams, grams. Now, why is it very important that you understand this? Because they give you the initial amount, and then they give you t. So you got to know where to put it in. Now, I know this is about as exciting as watching grass grow, okay? But, you know, carbon dating is more exciting when you actually do it in the field rather than do it in a math class. So I can't do much with it, okay? Y'all forgive me. I'm sorry. All right, and B, what percent of the original amount is found after 4,500 years? So now they want you to find Y. Okay, so F of 45 is equal to blah, 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 but this is going to be 0.58 times Y sub O. So 58% will remain. So write that down, 58% of the original. So I'm going to do, that's A. So B, I'm going to plug everything in. F of 4,500 is equal to Y sub O e to the negative 0.0001297 multiplied by 4,500. Now you're going to do the math, and you're going to get Y sub O times 0.58. And that basically means 58% of the carbon is still present after 4,500 years. Now, out of those 3 questions, you could have all 3 of them as test questions. So, along with, as far as 5.1 goes, along with being able to graph, solving a basic equation, you want to make sure you know compound interest and continuous interest, and you want to make sure you understand the decay in a carbon dating type problem. So out of 5.1, you got 5 type questions that I could ask you on the test. Okay, now let's get to logarithms, because that's what chapter unit 2 is all about. Now, the number one thing that you need to realize about logarithms is the definition of a logarithm. And I doubt very seriously that they started with that, because they hardly ever do start. Let's see if they did, because that's what you're supposed to start with. Well, yeah, they did. There it is right there. Definition of a logarithm. I'm going to write it down for you because they butchered it up. So I'm going to write it down for you right up under here. The definition of a logarithm. Now, you're not only going to use the definition of logarithm at the beginning of this section, but you're also going to use it at the end when you actually solve logarithmic equations. So if you don't learn it, you're really going to suck on this test. Okay? So, y is equal to log base A of x. I use A, the book uses B. And that's going to yield a glorified exponent. X is equal A to the y. Now that right there is the definition of a logarithm. On a scale from 1 to 10, on this unit, it's a 15. You've got to know this way, backwards and forwards. I can go from a logarithm to an exponent. I can go from an exponent to a logarithm. So take that example I gave y'all in the previous set of notes. 32 is equal to 2 to the x power. 32 is equal to 2 to the x power. See, this is an exponential. X is equal to 32. A is equal to 2. And y is equal to x. So now I put that x right here. Log base 2 of 32. Now, we don't know how to use the change base formula yet. I'll show you that in just a second. But I'm just showing you how this works. X is equal to log of 32 over the log of 2. And somebody do that in your calculator right quick. I'll do it. Log of 32, close parentheses, divided by the log of 2, close parentheses, and enter. 5. X is equal to 5. And in our problem, what did we find x equal to just using bases? X is equal to 5. So you can actually use the definition of a logarithm to solve an exponential, because a logarithm is a fancy exponential. Okay? And this right here is the change base formula. We're going to learn that in a little bit. So again, I need everybody I did. Did I give y'all a handout on? Did I give y'all a handout on exponential and logarithms? Yes or
I
no?
believe so.
Huh?
Yes.
I believe so.
Yes, you did.
I'll check.
Okay. Make sure somebody go look in the file section. Let's go look right quick and see what it's called. What did we call it? Anybody see it?
It's called EXP log prop.
Okay. EXP log prop is the third one down. Okay, so let's go ahead and click on it so everybody can see what it looks like. And here it is. Well, I don't know why it's doing it all funky, but anyway. There it is. I can't get the thing to work right, but something happened to it. Well, I don't know where it went. Damn Russians. Okay, now I done lost my white page again. I don't know how it does that, but now I done lost my white page. Anyway, to make a long story short, that's very important. And we could do several of these. I'm going to let you write those down. These are examples of going from an exponent to a logarithm using the definition of a logarithm. So you can write those down. I'll just do this as a slideshow. Okay, go ahead and write those down. Those are just examples. And yes, you probably got one test question right there. Okay. And you can go from logarithm to exponent or exponent to logarithm. Now, this isn't the only thing you're going to be doing. In the last section of logarithms, you're going to be solving logarithmic equations. And there again, you're going to see the definition of a logarithm. So you need to make sure you understand that you're not only going to see it at the beginning, you're going to see it at the end of the unit also. I wish I knew how to get my dadgum whiteboard back. There it is. There it is. And the definition of a logarithm is somewhere. Well, they don't even show it. Well, I'm glad I gave it to you. The definition of a logarithm, I thought it would be on here, but it's not. So much for that. Well, y'all got it written down, so that's all that matters. And there's three more. Write those down. I'm not going to insult your intelligence. I think most of y'all can understand how it works. But go ahead and write those 3 down. And make sure you write down the parent graph of the logarithm, because it's important. Exponentials and logarithms are not that, exciting. I'm sorry. I done lost half of y'all. All I got is, I got walls and ceilings. Really? Y'all hurt my feelings. At least I get a shoulder and, bed corners. It's better than walls and ceilings. Okay, I got a little bit of movement from Miss Jones. Got a little bit of movement. Now we got ceiling fan and forehead. An eye. We got an eye there. But the other 5 we got ceiling in the car, a window with a, bedspread on it, and a wall with a top of somebody's head. I think that's Mr. Beckett's head. It's always nice to look at the walls. Always nice, isn't it, y'all? Isn't it nice? Oh, there's Mr. Brooks. Settle down, Mr. Brooks. Mr. Brooks, you're entirely too loud. And there is your logarithm. Make sure you write down the logarithm, because anytime you do a logarithm, let's do log y is equal to log of x. Let me hit clear. Okay, y is equal to log of x. This is your basic model to put on your parent graph. Let me go zoom fit. There we go. So make sure you draw that in your parent graph. I don't like that. Let's do zoom standard. I don't like that one either, but that's about as good as you're going to get. Let me try zoom window and just get around the origin. There we go. Yeah, that's about all you're going to get. You can't take the log of 0, so that's why it never does reach 0, because you can't take the log of 0. Trace. And of course, don't hold the button down, because you get non-existent. You get non-existent numbers. There we go. And you see it stops at 0.02, but you can't take the log of 0. That's a test question. Make sure you know that. Make sure you know what the graph of log. I don't know why they picked log base 5. That's not a good one to pick, but anyway, there it is. There's the log right there. So make sure you know how to graph the log. We haven't got to the real good questions yet. There is a horizontal shift of 3 to the left. There is a vertical shift of 4 up and 2 to the right. So hopefully you can, do those. I'm not going to rehash over that. Write this down. The log base E is equal to the natural log. Log base E is equal to the natural log? I don't know how much logarithms y'all have had in the past. I would ask y'all, but y'all wouldn't tell me because y'all don't talk. But, you know, it is important in calculus that you know, because there is a whole unit on doing calculus with logarithms. So it's good that you know that log base z is equal to the natural log. A lot of people use log. I use log. It's just a preference. There's no difference between the two. Some people use 0.5. Some people use 1/2. Okay. Okay, now we're starting to get into most of your questions. Okay, go ahead and write down. You don't have to write these down because they're on your sheet that I gave you. But you can put them in your notes in case you want to, you know, these are just some little properties. But we're fixing to get into the bulk of the test, which is your rewrites. Let me go ahead and write down what your logarithm test is going to consist of. You're going to have a little bit of exponentials / log and graphs and vertical and horizontal shifts. Okay, that's going to make about 10 to 20% of the test. Then what is 80% going to consist of? 80% is going to consist of rewrites, solving equations. Okay, so, you know, your log test, you got, there's 5.1. We're doing 5.2 right now. This is 5.2, logs, graphs, and vertical and horizontal shifts. We're fixing to get into the rewrites and solving equations, change base formula, change base formula. All of these kind of work together. Okay? And that's what most of your test is going to come from. So if you're wondering why I'm being kind of nonchalant and kind of skipping over some of these notes, that's because we're only talking about 10, 20% of the test right now. And hopefully y'all trust me. So, and there is your three main, this is part of the 80% right here. So I want you to go ahead and write those down. If you haven't got that sheet that I sent you, print it out. Those three right there, along with the definition of a logarithm, make up the bulk percentage of your logarithm test. I'm going to write them down. So y is equal to log base a of x yields a to the y is equal to x. That's the definition of a logarithm. Number one. Number two, product rule. Log base a of m times n is going to yield log base a of m plus log base a of n. That's called the product rule. Three, the quotient rule. Log base a of m divided by n yields log base a of m minus log base a of n. And then the power rule. The power rule says if I have log base a of m to the k, then that's going to yield k times log base a of m. And then the change base formula is equal to log base b of a is equal to log base 10 of a over log base 10 of b, or natural log of a over natural log of b. Either one, it doesn't matter. There is 80% of your test right here. Okay, this is the definition of a logarithm. This is your product rule. I want you to learn the names. That there where you think I'll take that number and you move it on up there, that don't cut it. You got to know the names. Quotient rule. Power rule. And the change base formula. %80 of your test is right here. Well, Hubert, I thought you said solving equations. That's how you solve equations. You use the definition of a logarithm, use the change base formula, or you use rewrites to solve equations. So if you didn't print out that sheet, if you did print it out, then you need to highlight these 5, because these 5 is what you're going to be tested on. I know I'm repeating myself. Do I do that intentionally?
Mhm.
Yes. Why? Because most students it has to be repeated 3 to 4 times, most students. Miss Garcia, don't you want to be a teacher?
Definitely not.
Yeah, well, I couldn't deal with the public like you do.
It has its perks.
I have people come by when I'm baling hay, and they'll come by and they'll say, "Do you sell your hay?" And I say, "Hell to the no." Well, why don't you sell your hay? Because people bitch. That's why I don't sell hay. And they get mad at me when I tell them that. All right. So let's look at some of these. And I'm going to cover up what they're doing, because now I'm going to start doing problems with you, because these are the problems these are test questions. And look at the directions. What does the directions say? Read what? Rewrite. Either your directions are going to say rewrite, or they're going to say solve. Okay, so this one says rewrite. A, log base 3 of x plus 4 log base 3 of y. Okay, so there's your test question. And I'm going to give you 30 seconds. Go ahead. I'm not going to count, but I'm going to give you 30 seconds to do that problem. Rewrite. And if you can't do it, then that means you're pretty much a failure. Right, Mr. Bostic?
Yeah.
Well, I sold all my stock on one page so I could buy more GameStop and AMC, and I gotta wait 2 days before I can buy it. I forgot about that.
What do you use to buy Shiba?
What'd you say?
What do you use to buy Shiba?
I had to, oh my God, I had to go through pulling his teeth. I had to go to Cryptocom, Cryptocoin or Cryptocom,
Yeah.
Crypto. And then you have to release your, if you don't use a credit card, if you use your debit card, you have to go through your bank and you have to disengage your debit card in order for crypto to use it. Does that make sense?
Yeah.
Because some debit cards will not let you do stuff internationally.
Okay.
So you have to sign a waiver for 24 hours and then do whatever you need to buy. I want to buy another set of Shiba, but you know, for $100 you can buy like 1 million. So if they ever get to a penny, you've got 70,000.
Yeah.
I mean, you can't lose. I mean, unless you just, you know.
And what did you say you went to? What website was it?
Crypto.com. All right. So first of all, log, watch what I do because this is the best way to do it. Power rule, log base 3 of y to the 4th. And then this right here, wait a minute, let me take a highlighter. This blue shows you the power rule. I use the power rule. And now this for yellow, I'm going to use the product rule, and I'm going to rewrite as, since these are the same bases, log base 3 of x times y to the 4th. And that is your final answer. That's a test question right there. Question, gripe, complaint.
On that, when you're writing down the rules, what was the
Ma'am?
last one that you had on there?
Okay, here you go. Thank you for communicating, Miss Taylor. You're such a good communicator. You're going to have a nice office one day. They're not going to put you in a closet janitorial office. They're going to put you in a nice office.
All right, thank you.
Yes, ma'am. All right, now let's do the other one. You do that one. Do B. One half log of A minus 3 log of B. Now, let me go ahead and tell you, if there is no base on the log, it is assumed to be what? 10. If there's nothing on a log, it's assumed to be 10. Go ahead and tell you that right now. And you need to make a note of that. There's 2 logs in mathematics. I'm going to write this in red. There is log base 10, which is log, and then there's log base E, which is natural log. Always remember that. Did you find crypto yet, Mr. Mosul?
Say again?
Did you find crypto yet?
Yeah, I found the website.
Well, make sure, and if you got a credit card, you can use it. But if you use a debit card, you're going to have to call your bank and have them waive it for 24 hours, or you can waive it indefinitely, but I didn't waive it indefinitely because I want that protection there just in case.
Yeah.
All
Unless
right,
there's any other places
so
that it
log A of 1/2 minus log B of 3. And since you got the same base, log base 10 and log base 10, you can write this as log of A to the 1/2 times B to the 3rd, or log A to the 1/2 B to the 3rd, or log square root of A times B to the 3rd. You know, any of those would suffice. Now, those are two good test questions, but they will evolve into more challenging questions. These questions will evolve. And see what they got. Oh, shoot. I didn't divide. Sorry. Divide. I did multiplication. I'm sorry. My bad. Okay. And they got A to the 1/2. You could do the square root as division. All right, try C. Hopefully I won't mess that one up. Try that one. And the only difference here is they're just switched over to a natural log. So C, natural log of 5x minus 3 natural log of z. So take a second or two and do that. Question, gripe, complaint. Well, that's going to be same base. This is log base E of 5x minus 3 log base E of z. So they do have the same base, and they're both natural logs, so you can use that as the same base. This 3 is going to go up here, so log base E of 5x minus log base E of z to the 3rd, and that's going to be log base E of 5x divided by z to the 3rd. Now, a lot of people ask, Hubert, why'd you change it into log base E? I'm just showing you that those two are the same thing. You don't have to change it to log base E. You could just do natural log of 5x minus natural log of z to the 3rd, and then go from there to there. Natural log of 5x over z to the 3rd. Now, 5.3, I think that's where you're going to see a lot of your equations. Let's go ahead and look at some, because that's what the rewrites in the equations, that's where you're going to see most of your test questions. Now, what I'm going to do is I'm going to show you just a question, and I want you to see if you can solve it. Well, that's not what I wanted. Oh, why can't they do things simple? That's not what I want. Well, there we go. All right, look at those two problems right there. I want you to write both of them down. I want you to see if you can solve them. 4096 is equal to 8 to the 2x. And the other is 6 times 4 to the 3x minus 2 equals 120. All right, take a minute and see what you can do with those two. GameStop is down today. That's good. At least I'll buy some more and then I want it to go up. Now, I don't know my eights. I don't know my eights, so I'm going to just giggle since I've got exponents. I'm going to go over here and I'm going to go 8 to the third power, 8 to the fourth power. Look at there. It's a miracle. So I'm going to change this. 8 to the fourth power equals 8 to the 2x. And I've got the same bases. Therefore, four is equal to what? 2x. If the bases are the same, the exponents are what? Equal to each other. Therefore, divide by 2, x is equal to 2. Now let's check that with the definition of a logarithm. Because you have an exponent here and you can change an exponent to a logarithm. Y is equal to log base a of x yields a to the y is equal to x. Well, we've got the exponential right here. So 8 to the 2x is equal to 4096. So that's a, so y is 2x log a is 8, and of course x is 4096. Now it looks like we're going to take change base formula. You don't know it yet, but 2x is equal to log of 4096 over log of 8. And we're going to divide that by 2. So that's another way you could do it. So we're going to take our handy dandy calculator. And we're going to take log, parentheses, log of 4096 close parentheses, divided by log of 8, close parentheses, divided by 2. And you get 2. So you see, you can solve an exponential with exponential laws, or you can solve it with logarithmic rules. And this right here is the definition of a logarithm. Okay, up here, I don't know, excuse me, I'm going to divide by 6 first. 4 to the 3x minus 2 is equal to, 6 will go into 120 how many times? 20 times. And I can't do 2 to the first, 2 to the second, 2 to the third. I can't do anything with that. So I'm going to have to take I can do this, or I can take the log of both sides. I could do that, or I could take the log of both sides. So log 4 of 3x minus 2 equals log of 20. And this comes out front using the power rule. 3x minus 2 times the log of 4 equals log of 20. And divide by log of 4. Divide by log of 4. 3x minus 2 is equal to log of 20. Log of 20 divided by log of 4. 2.16 blah blah blah. 2.160964047, and you're going to add 2 to that, and you're going to divide by 3. So add 2 to that, and divide by 3. 1.3869888 blah 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 blah. I don't know what they got, but let's see what they got. Well, they got x equal to 2 for the first one. We got that. And 1.387. Question, great, complaint. All right, let's go do another one. All right, let's cover that one up. Another test question. Go ahead and start on this one. 4 log base 3 of x. 4 log base 3 of x is equal to -8. Now, I would bring that 4 up, and I would get log base 3 of x to the 4th is equal to -8. And I'd use the definition of a logarithm. And y is equal to log base a of x yields a to the y is equal to x. So this is y, this is a, and this is x. A to the y, 3 to the -8 is equal to x to the 4th. This right here is going to be 1/3 to the 8th. Take the 4th root of both sides. And the 4th root of 3 to the 8th is squared. So that's going to be 1/3 squared equals x. And I think it's going to be x is equal to 1/9. I think. Now, I don't mean to scare you, but can you see how some of these can be a little bit more challenging?
Yeah.
You may think you know it and then turn around and you don't. 1/9. Dang old. We smart. And we only scratching the surface with these slides. All right, there's another one. 6 plus 3 natural log of x equals 12. Six plus 3 natural log of x is equal to 12. All right, give you a minute to get it started. I would start by subtracting the 6. And you get 3 natural log of x is equal to 6. Use the power rule. Natural log of x to the 3rd is equal to 6. And that's log base e of x to the 3rd is equal to 6. And whenever we have logarithm, y is equal to log base e of x, and that's going to yield base a, and that's going to yield a to the y is equal to x. So e to the 6th is equal to x to the 3rd. And I'm going to take the cube root of both sides. Well, that's the 1/3 power. So e to the 6th to the 1/3 is equal to x. And that's going to give us e to the 6/3 which is equal to e to the what? E squared. Yep, e squared. Still haven't got to the problems I want to get to. Problem I wanted to get to, but I'm going to stop right here, is one with a rewrite. There's one. You could do that one. Yeah. Well, where'd it go? That one right there is the one I would put on a test in a heartbeat. Natural log of x plus 3 is equal to the natural log of x plus 4. So that's one you can work on with your homework. Excuse me. Natural log of x by itself plus 3 is equal to natural log in parentheses x plus 4. All right, let's shut her down. And let me pull up the attendance and shut off the recording.